I'll talk about what is Spark SQL and what is a data frame, and I'll give you some pointers as to where you can find out a little bit more information. And then we'll talk about data analysis with Spark using weather data. I'll tell you a little bit about the data, some initial steps, and how easy it is to program in Spark. You'll be surprised as to how easy it is to run some of these commands in Spark. And then without going into any further detail, I'll just show you some graphs. Okay, some graphs as to the outputs and the results that you can get from Spark. Okay, so starting with Spark SQL. Spark SQL is Apache's module for working with structured data. So the focus here is structured data, right? And it provides a programming abstraction called data frames, which is in fact borrowed from R data frames or Pandas data frames, and can also act as a distributed SQL query engine. So you can actually run SQL statements with Spark data frames. Okay, so if you want to know, if you want to select a particular column from a particular table, you can do that in Spark. It makes it very easy. Okay, for more information, you can go to this link, and I'll provide you guys access to the notebooks afterwards. Okay. Okay, so let's talk a little bit about weather. So as you know, as you may have heard, IBM recently acquired their weather company. So weather has become a bit of a focus here at IBM. Or at least within my team, I believe. It also relates very well to Big Data University's goals because we're trying to align ourselves with the with the United Nations goals, including climate change. So we have this data set on weather, and we have multiple weather stations throughout the world. And at each of these weather stations, we're recording measurements. I'm not sure why it's, oh, okay, great. Okay, so we have multiple weather stations around the world. So in each city, we can say like Toronto has a couple of weather stations, one in Pearson Airport, Winnipeg has one, Vancouver has one, Halifax, there's weather stations around the world, right? And then when we watch TV, it's all the data that they've collected from these weather stations. For this tutorial, we're only looking at weather stations in China. Now, again, there's also many different weather stations in China, but we're focusing here on 31 weather stations, okay, throughout China, okay? And for each kind of row in this table, what we have is these kind of variables. We have the ID, which is the ID for that particular station. We have the date of the observation in which something was recorded, for example, precipitation, or whether we're recording temperature, or we're recording maximum temperature or minimum temperature on that particular day. And we're also recording the actual value. So what was that temperature? What was that amount of precipitation? Next is a different data set. It's called stations. And what stations has is, again, a list of the IDs, but it also has exactly where these stations are, the latitude and the longitude. We also have the elevation, how high it is above sea level, and also the actual name. So these are IDs versus names. IDs are just letters and numbers. Names are the actual places. Okay? So the goal here is to just first merge these two data sets together, get it into Spark, and try to visualize it as best as we can on a map, okay, okay? And see how it changes, how the weather in China has been changing from 2005 until 2014 across every day or across every month, okay, or across every season, okay? So we begin by getting the data, and Leo showed this a bit earlier, but we use bash, we use wget, so we're just downloading the data. And I've run this already, so I don't need to run it again. But here we've downloaded it, okay? And next, we create what's called a Spark SQL context on top of SC. So remember, Spark context SC is your connection from your account on Data Science Workbench to a Spark cluster. But instead of having a Spark cluster in Data Science Workbench, we're only looking at Spark on a local machine, right? On the local cloud environment, if you will. So this is a SQL context that kind of plays on top of this SC, okay? This is Spark context. And the SQL context allows us to create data frames, okay? It allows us to create these tables and work with tables. Now first, we need to import this CSV file as a Pandas data frame. And Pandas is a package in Python which allows you to analyze data in these kind of tables or in these data frames. And you can do lots of stuff in Pandas data frames. You can do sums, you can do counts, you can remove columns, you can aggregate columns, you can merge data sets, you can do basically anything you want. So for every cell in a particular column, you want to add a 0, or you want to round it to the nearest integer, or so on. You can do all sorts of stuff with Pandas data frames. And okay, so here we're importing the CSV file as a pandas data frame. And I'm doing a little bit of extra stuff here, like adding a few columns for the year, month, and date. And we can take a look at the first 4 rows. So as I said, we have the station ID, and we have the date at which the measurements were recorded. We have the elements, whether it's maximum temperature, min, precipitation, or average temperature. And we have each of these values in Celsius. Okay, Celsius or millimeters for precipitation. We have the year, month, the date of the observation. Okay, so that's our first data set. And here we see the number of rows and the number of columns for this data set. We have 398,473 rows. We have 7 columns. It's not big data, right? It's all fitting somehow on the machine, but it's not really small data either. Okay, so here now we're merging data from station CSV. And the reason why we want to merge is because we want to add the location data, the latitude, longitude, elevation, and name. We want the latitude and longitude so we can plot on a map. So here we're reading this in. And we're using pd.merge, which allows us to merge the 2 data sets. And we merge it based on a left join. And here we have it. So at the very end of this table, now we have latitude, longitude, elevation, name. And of course, these are all observations from the same station, from Harbin. Okay. I need to study a little bit more about Chinese geography too. I'm very bad at this. So this is, yes, maybe you can teach me. Okay, so here we're creating, so before here, we're really looking at pandas data frame so far, right? This is the pandas data frame. If you can't tell, it's because, well, I use pandas in the code. But if we want to convert this into a Spark data frame, it's very easy. It's just literally just one line of code, SQL context.create data frame. And we're converting this pandas data frame, PDF, into a Spark data frame. And it's just one line of code. It's very easy. You're converting from something that a lot of even data analysts know how to use in Python, and convert that into a Spark data frame. And we see that we confirm that the type of this data frame is indeed a PySpark SQL data frame. Okay? And then now we can print the schema of this table, which is this. We have, I think, 10 or 11 or so columns, and some of them are strings, some of them are doubles, and so on. Okay? Now, we can first compare the syntax between pandas and Spark data frames, and you can see how similar they are. So if you know pandas data frames, which a lot of people, especially data analysis, know, it's very easy to convert between pandas and Spark data frames. In pandas, we're looking at, let's say we want to look at the first 5 rows. So that uses head in pandas. Head, and then 5. In Spark, it's sdf.show, and then 5. Okay? Now if you want to look at the schema, which is what we did already, in pandas, we just take a look at the types for each of these columns. For Spark, we're looking at the schema, print schema. For select, in pandas, you have to use square brackets and write down which column you want. And then, of course, here we're just taking a look at the first 5 rows. So these are the first 5 IDs. Okay? This is another way to express it in pandas, just using the dot syntax. I won't go through this in too much detail. I don't want to have to explain all the syntax in case you don't know Python, right? But I'm just kind of doing a comparison between Python and Spark to show you how similar it is. In Spark, instead of using the square brackets, you use select. Again, it's very easy. It's very verbal, so it's very easy to pick up. If you want to choose multiple columns, in pandas, it's a list within kind of like a list, or a list between the square brackets. But in Spark, now it's just select, round brackets, and then whichever variables you want. It's very, very easy. Next is filters. If you want some condition applied to your data frame. In pandas, you use this kind of condition here within the square brackets. So we want the value 1 to be less than 0. So here now, all these values in this column is less than 0. In Spark, it's almost exactly the same thing, really, except we use filter. So filter, and then your condition, and then we take a look at the first 5 rows. So it's very, very easy to kind of convert between the two. And again, between multiple columns, so multiple conditions, here we're just adding in an ampersand, an and, to add in 2 different conditions. And for Spark, again, for filter, you add in 2 different conditions. It's very easy to pick up. Okay? Of course, if you want to group by a particular variable, so let's say we want to group by the stations, or we want to group, and we also want to group by the type of measurement, for example, maximum, minimum, temperature, and the precipitation, we can have these two column names, and we want to do an aggregation by the count. We can do that, right? So this is by the ID and the element. And for Spark, it's also very, very easy. Group by, and then we do a count. Okay? Now we can also convert between Pandas and Spark very, very quickly. Just one line of code each. Okay? So now one of our first goals is let's actually visualize this data, right? Let's understand what this data is all about. So here, our first question is, which months in China have the most amount of precipitation? Okay? And here, because we don't want to clutter our line graph to too many cities, we're going to look at Beijing, Haikou, and Shanghai. Beijing, Haikou, Shanghai. Okay? And we're going to group by every month, and by each month, and by each of these cities. And here we're looking at the average precipitation in millimeters. Okay? So next, we can plot this. And we're using matplotlib. We can plot directly using Spark data frames. And here we see Beijing in blue at the very bottom, Haikou in green, and Shanghai in red. So you can see Haikou, because of course it's south, it's more closer to the coast, it gets a lot of more rain. I'm guessing also because of typhoon, right? Maybe, right? But Beijing and Shanghai is more inland, so it doesn't get as much rain, I think. I'm not too sure. I'm not a meteorologist, okay? Don't trust what I say. Okay, so we're doing once in Spark and once in Pandas, showing exactly the same thing. It's very easy to do. Okay. And next, we want to take a look at the annual precipitation. So from 2005, mislabeled this 2005 to 2014, how has the amount of precipitation changed over the cities? So you can see with Haikou in I think 2008 or 2009, it really had a lot of rain, but it overall still has a lot more rain across all the years compared to Shanghai and compared to Beijing. We're going too soon.
我说一句，就是可能大家有些疑问，就是说他现在看到这个结果是他已经运行完了的结果，随后呢你运行扣了以后产生这个结果。
Okay. Now we can also take a look. Is there more or less precipitation with higher elevation? And remember, we're kind of creating these questions as we go along to kind of explore the data, to understand the data a little bit more. There's a more or less precipitation with higher elevation. And here we're using, again, we're using Spark, we're using Pandas, and we're using matplotlib to graph this. And you can see here, at the bottom here we have elevation from 0 meters up until 2,000 meters, very high up on the mountains. And we have the amount of precipitation. So you can see that no, there's not a huge trend. Maybe there's a bit of a curve here, it seems. But there's a lot of missing data here between some of these elevations as well, so it's hard to tell. But of course, there's a lot of precipitation at sea level, right? But there's also some precipitation around 400 perhaps as well. Now let's try to plot this on a map. So here we've only kind of looked at the line graphs with only 3 cities. Here we're looking at all the cities, but it's still not very interesting. Let's plot this on a map. We're going to plot all the precipitation, temperature, and so on a map, and let's visualize it by location. So first, let's take a look. How many stations are there to plot? So you have Beijing, Benji, Changchun, and so on. So we have 31 stations. And then we can create some functions here to help us with the plotting, which I'll skip. This is kind of what it looks like. We have, how many do we have? We have 304 measurements in total across 31 stations. And let's go ahead and plot it. So we're using this package here called BaseMap. And for those of you who want to learn a bit more about BaseMap, please talk to me afterwards. And here we can plot the amount of total precipitation by year in 2005 only, okay? So the size of these dots corresponds to how much precipitation there was in that particular year, okay? Or in that particular city. So you can see some smaller dots, has very little, okay, has very little precipitation, very, very inland. And then we have Guangzhou has a lot of precipitation. Nanchang has a lot of precipitation as well. So I'm guessing these are particularly areas that are affected quite a bit by typhoons. And this is just for 2005, right? So now we want to create another map for 2006, right? So 2006 shows roughly the same pattern, I think. And 2007 also shows a slightly different pattern, but this is very difficult for us to visualize. Time to scroll up and down, right? How do I keep going between, how do I compare between Nanning from here until 2006, and it's here, and then up until down. So what's the best way to visualize this is to animate the plot. So to animate from 2005, 6, 7, 8, 9, and so on. There's a package in Python, because Python you can do so many different things with it. There's a package called MoviePy, which allows you to create animations, and that's what I've done. So here I'm installing MoviePy in Data Scientist Workbench. Pip install MoviePy. I don't need to run it again, so I kept it like that. And we can scroll down just to see the output. So let's take a look here. Oh, I can't make it full screen. It's okay. So we can see at the very top it says 2008, 9, 10, 11, and so on. So you can see how the amount of precipitation changes over time. And there's some years where there's a lot of precipitation in some of these cities, but in most of the other years there's not so much precipitation. Like sometimes it just goes very, very large. And you can see how you can apply this to many different data sets as well. So not just weather. What if we looked at earthquakes and changed the size of the circle to represent the magnitude of the earthquake? Someone has done that for Japan. There's a 2013 earthquake, 2013, 11 earthquake. It's very large. You can see how earthquakes kind of explode in activity very close to a very large earthquake. So this is the total precipitation by a weather station in China across the years. But we can also look at the average summer versus winter, because temperatures in 2005 to 2000